Okay, so in this one we've got a reaction, an equilibrium reaction of 2p going to S and T. We know we start with 1 mole of P and Kc is 36, and we need to find the number of moles of S and T. So let's start with writing out the Kc expression. Kc would be equal to concentration of S over the times concentration of T over the concentration of P squared. Okay, now we can do what we did before, which is change this or express it in an algebraic way. So if you have 2p in equilibria to S and T, and we start with 1 mole of P, well, you must end up with, let's say, F moles of S. Got a little bit of a problem. If I've got F moles of S, I've got F moles of T, and I must have lost F moles of P. The problem is I've got 2 P's. Then if we look at the ratio, the proportion of S to P's, we have twice as many P's, or in other words, half as many S's. So we can divide each of these by 2. Okay. Now, we would divide them by volume to find concentration, but I'm not going to, because I've got 2 terms at the bottom, or granted this is P squared. This actually means, just to recap, P squared in square bracket is P times P. So as I said before, if you have the same number of terms at the bottom as the top, the volume will cancel itself out. And now I'm going to take this, and knowing that a lot of pupils nowadays don't like fractions, you're not taught fractions, more you're taught decimals, you work with decimals. What I'm going to do is rewrite this as 0.5f and 0.5f. Okay. So now what I'm going to do is I'm going to take my Kc expression and I'm going to substitute into my Kc expression these values, which would be 0.5f times 0.5f divided by 1 minus f, and we must square all of it, not just the f. Alright, but if I look at that, and if I look at how to write that, I see something. And what I see is 0.5f and 0.5f would be multiplied together, so I could rewrite it in a more simpler form. Kc is equal to 0.5f squared over 1 minus f squared. We're told in the question, I said at the start, Kc was 36. Now, for all those who are good at maths will realise that 36 is a square number. And if we take our expression, we must put squares all over the place, and we can square root the entire expression to give 0.5f over 1 minus f. Careful, the square root of 36 has 2 possible values, either plus 6 or minus 6. Now if you've got this far, well done. If you're not a mathematician, leave it. If you've got this far, that's all you really need to do, because you don't want to spend lots and lots of time solving this. For all those who are mathematicians, well, you don't really need me to explain this bit. If you do, check out the next bit.